Good afternoon, my people. Welcome to week 6, geometry. Hope you all are doing all right. I think I cut a little bit out of my thumb the other day, but otherwise doing just fine. Today we're going to get into trig ratios. Now, trigonometry, it just stands for the nometry of triangles. It's not that scary. It's going to be fine. And this is just a brief intro. So that's all I really want you to get out of this. So we're just going to go over this one little chunk section. So if you see, we're going to do the introduction to trigonometric ratios. So go over 2 videos and do 1 practice. Really not that much. So the first video is Intro to the Trigonometric Ratios. So ratios is something that we should have an idea about since we've been doing ratios with similarity. But you'll notice up here, oh shoot, oh come on, you ding. So up here, there's going to be kind of steps. So it says tip, but think of it like steps. So when you're doing anything with trig, especially with these right triangles, the first thing you want to do is find the hypotenuse. Now the hypotenuse is a word you've probably already heard before. Maybe you haven't, that's fine too. But it just means the longest side of a right triangle. Now, you should have heard this already because we used it with Pythagorean Theorem. A squared plus b squared equals c squared, and c squared was the hypotenuse squared. So this word should ring a bell. Now, remember what we did to find the hypotenuse. It's the longest looking one, so that's your first indicator. And it's the one that does not make up the right angle. See this? This is the hypotenuse. And here is the right angle. The hypotenuse doesn't touch this angle. It's like if I was going to make a little circle that indicates that angle, this side and this side, but not the hypotenuse. The hypotenuse doesn't even touch it. So remember that this square inside the triangle means it's a right angle, and the hypotenuse is the one that's not touching that square. You can even look for the square. And we also say it's opposite the right angle. That's a word we might start using. So whenever we're doing trig stuff, you always want to just note on your triangle which one's the hypotenuse. This is the cool new stuff. Sine, cosine, tangent. What do these words mean? Well, they're just specific ratios inside triangles. So a ratio, remember, is just a fraction. And in this case, the fraction is going to be made up of side lengths. So the only new thing that you might see is this theta. It's a Greek symbol. Looks like a 0 with a line through the middle. It just indicates an angle, where the angle is. And sometimes they won't even use theta. Theta is just the general. Sometimes they'll use all weird types of Greek letters, but it'll be inside the triangle, okay? And theta is what we usually say. What is this weird long thing? Sohcahtoa. It is a mnemonic device to help you remember. So, that's sine, ka, cosine, and toa, tangent. These are the ratios that you will learn, and just through repetition we'll just start to get. But just so we can go through it all, sine of theta, that's how you would say the sine of theta equals the opposite side over the hypotenuse. So that just means a number here, the length of this side, the opposite side, over the length of the hypotenuse side. Ka stands for cosine equals adjacent over hypotenuse. Opposite hypotenuse, opposite adjacent. Cosine of theta equals the adjacent side over the hypotenuse side. See, it feels so arbitrary, but it's actually really beautiful in how this just works, that this ratio works. Anyway, so tangent of theta equals opposite over adjacent. So those are our trig ratios. Those are it, those 3 things. I mean, those three things are made up of three things each, but we'll get to them. So your first step was to find and note the hypotenuse. So whenever you're doing any of these problems, just find the hypotenuse first, then find where theta is. So theta is one of two angles in a right triangle. The trig ratios, we don't care about using them with the right angle. It'll just be one of these two angles. The corner ones that aren't the 90-degree angles, because we just don't use the sine, cosine, or tangent with a 90-degree. Mostly because it gets weird with the hypotenuse and the opposite. Yeah, it just doesn't work. So remember, there's only the three angles inside every triangle, and if we're dealing with a right triangle and we can't use this right angle, then theta can only be one of two angles inside. And just so you can see it, no matter where we put theta, one of its sides is going to be the hypotenuse, right? So if theta was over here, that angle would be made up at least on one side by the hypotenuse. Theta is over here, here's the hypotenuse. All right, let's keep moving. So find and note hypotenuse, find and note theta. The next step is find and note the opposite side. So the opposite side is the one not touching theta, not making up that angle. Okay, so here's theta, right? And it's being touched by hypotenuse here, and whatever we're going to call this. I mean, let's pretend you don't know what that is. So this opposite side is not touching this angle at all, right? It doesn't make up this angle. The other way you can think of it that I just came up with, and it might not work, but it kind of works, is that think of it like the crust of the pizza, okay? It's not touching that inside tip of the pizza. The crust is opposite it, okay? So the opposite side is always the crust. This gets a little tricky when we have to find multiple sides and you have to change what the opposite is, but I'll go over that in a second. All right, adjacent side is the one that's not the hypotenuse, but it also is touching theta. It's the one that's next to theta, and the one that's next to and not to the hypotenuse. So one trick that I like to do when I want to make sure that I've named them all is I start at theta, and if I go towards the right angle, then that's my adjacent side. And if I keep moving away from theta, that next side is my opposite side. And if I keep following the path, this last side is the hypotenuse. So if you're ever really stuck and you want one last way of figuring out what all the sides are, start at theta and move towards 90 degrees. That side that starts at theta and goes towards 90 will be your adjacent, and then you just keep going from there. Adjacent, opposite, hypotenuse. Doesn't matter which one, but these are your steps. Find the hypotenuse, find theta. Why did Siri just start? Find the opposite, find the adjacent. And it's important to follow these steps because let's say theta is here. First step is to find the hypotenuse. The hypotenuse is right here, right? And then what's the opposite? Opposite is not touching theta. So that's here. And I want you to note that this triangle and this triangle are exactly the same. I just copy and pasted. So I've found hypotenuse, I found theta. Opposite, almost last step is the adjacent. So adjacent also makes up theta, and also if I started at theta and went towards the 90 degree, that's the adjacent, opposite hypotenuse. Now, just note what happens if I change theta. So hypotenuse hasn't changed. That's why it's the first step. Find the hypotenuse. This is the side that's still opposite. Let me change colors. The hypotenuse is still opposite the 90 degree. So that didn't change. Find theta. That's changed. So now theta is down here. And if I do my other step, the one I had for adjacent, well, let's just follow the steps, but I'll show you how it works. The side that's not touching theta is your opposite, and the side touching theta that's not the hypotenuse is your adjacent. And does that work? Moving from theta to the 90 is my adjacent, moving away from that is my opposite, and coming back is my hypotenuse. So that works. Now, look at what happened. It's the same triangle, and the same hypotenuse, but depending on where my theta is, my adjacent and opposite change. So the ratio changes depending on where my theta is. This is important to note. Alright, so let's try this out. The last step is use your trig ratios. So if I say theta is here, well, first step, we know this is the hypotenuse, right? And if theta is there, then this one's opposite. And this is adjacent. That looks like a D itself. Okay, so then if I want the sine of theta, I look over here, and that's SOA, so it's opposite over hypotenuse. So opposite is 3 over hypotenuse, 5. That's it. That's why it's so important to be able to correctly note which side is which. Because once you have that, you're done. As long as you can correctly read this. Cosine theta, that's this one. Adjacent over hypotenuse, 4. Adjacent over hypotenuse, 5. 4 over 5. And the tangent of theta equals opposite over adjacent. Opposite over adjacent. There you have it. Those are trig ratios. Now the next video, using trig ratios and right triangles. So they want you to remember Pythagorean Theorem. So the first step is you might have to figure out, actually on the practice you won't have to do any of this, but as you progress, you really have to start combining all of the things that you've learned. That's why you learn them, so that you can learn more stuff, right? So if I was going to do, I have to find this, right? I just got a text about a cake. I don't know. I don't want cake right now. So 7 squared plus 4 squared equals n squared. And they did this for you in the video, but I'm just showing you again. So 7 squared is 49 plus 16 equals n squared. So that's 60, whoops, that's ugly, 64 equals n squared. So n equals the square root of 60, whoops, not 64, 65. Good thing I have the answer already. Okay, so it gets a little tricky now. I mean, you don't have to trick it out, but say I find the sine of this theta. It is, oh yeah, so do your steps. This is the hypotenuse, right? And you know that from the Pythagorean Theorem. Opposite is over here, not touching theta. And then this must be adjacent, the last one. So opposite is 7 over the hypotenuse, 65. Now there's a thing about simplifying square roots. I don't really care right now that you simplify square roots. I just want you to be able to do this. Cosine adjacent over hypotenuse, and finally tangent is opposite over hypotenuse. Now, if you want to really know how to simplify that square root, email me and I can show you. but it's not important right now because the practice is just finding all your things. And to do this, I just really want to like show you the importance of the steps. Hypotenuse, and then if that's theta, remember I told you they get weird sometimes, then the side not touching it is your opposite. The side touching it that's not the hypotenuse is your adjacent. So this is the first 4 steps. Find the hypotenuse. Theta is already there. This theta. Find the opposite and then find the adjacent. Now you have to use your trig ratios. Okay, again, they're using beta, but that's just same as theta. But I can do hypotenuse. And if that's my theta, then that means that's my opposite. And this is my adjacent. Bingo bongo. Step 1, step 2, step 3, step 4. Right away, hypotenuse is this one, not touching the 90 degrees. Where's my theta? It's down here. My alpha. Opposite side, way over here. Way over here. You got to move it now. Adjacent. Oh gosh, doing so well. Okay, hypotenuse. I'm just going to use H. Opposite. Well, I guess here's theta. Opposite and adjacent. That's it. Then you got to use your sine. Then you got to use your trig ratios. And then they're just looking for that you have the right side in the right position of the fraction. Okay? Well, hope you're doing well. Miss you. Talk to you later. Bye-bye.